In the year 2021, the world has consumed around 176,000 terawatt hours of energy, out of which 147,000 terawatt hours or 83% of energy was produced through non-renewable sources like coal, oil and natural gas. These sources are considered as dirty sources as they tend to pollute the environment at large scale. 7,000 terawatt hours or 4% of energy was produced through nuclear reactors, which are semi-dirty source as they possess risk of radiation leakage. Remaining 22,000 terawatt hours or 13% of energy was produced through renewable and cleaner sources like solar, wind, hydropower, etc. These non-renewable sources tend to satisfy a major portion of world's energy requirement. But apart from energy, they produce something else too, pollution, in the form of smoke and waste residue, which in turn leads to a rise in global temperature. A correlation of increase in use of non-renewable resources for energy generation and change in average global temperature can be seen here. Horrifying, isn't it? At this pace, major portion of Earth will be uninhabitable in near future. So what can be the solution to all this? Renewable sources of energy. At least, renewable sources of energy do not produce pollution during energy generation process. But how can we switch over fully to renewable sources and meet the world's everlasting demand of energy? What is the thing that is freely available all around the globe? Sunlight. As per NASA's report, quote unquote, the sun is the major source of energy for Earth's oceans, atmosphere, land and biosphere. Averaged over an entire year, approximately 342 watts of solar energy falls upon every square meter of Earth. This is a tremendous amount of energy, 44 quadrillion watts of power to be exact. As a comparison, a large electric power plant produces about 1 billion watts of power. It would take 44 million such power plants to equal the energy coming from the sun. Due to Earth's tilt, the places around equator receive this much amount of energy throughout the year, whereas moving further north or south of equator reduces the amount of sunlight received throughout the year. The solar panels are only 15 to 20% efficient, but still, it's a lot. An average solar panel can generate 300 watts of electricity, and places near equator gets approximately 8 hours of high intensity direct sunlight throughout the day. So for generating 176,000 terawatt hours of energy over the year, we need only 330,000 square kilometers of solar panels. This is where Sahara Desert comes in handy. The Sahara is the world's largest hot desert, covering 8.5 million square kilometers, about the size of South American country Brazil. Sahara makes up 25% of the African continent and is approximately 1000 km north of equator. Being a hot desert, it receives ample amount of sunlight throughout the year. Further, precipitation in the Sahara Desert is scarce, as the whole desert generally receives less than 100 mm of rain per year, except on northernmost and southernmost edge, as well as in highest desert mountains. This means less number of cloudy days. The Sahel is a narrow band of semi-arid land that forms a transition zone between the Sahara to the north and the savannas to the south. It is made up of flat, barren plains that stretch roughly 5,400 kilometers across Africa, from Senegal to Sudan. The Sahel contains the fertile delta of Niger, one of Africa's longest rivers. Unfortunately, the Sahel's fertile land is rapidly becoming desert as a result of drought, deforestation, and intensive agriculture. This process is known as desertification. Since intensity of solar energy received from the sun is higher near equator, hence making an array of solar panels in Sahel region from Atlantic coast in Senegal to coast of Red Sea in Sudan will serve the purpose of generating enough energy for whole of the world all year long. This array will not be too huge, only 5,400 kilometers long and 61 kilometers wide. This will serve two purposes: generating enough energy for mankind and help reduce desertification of the grasslands to the south of Sahel. The wall of solar panels 61 kilometers wide will act as barrier between sunlight and ground, creating a large area of shade which can act as ground for plantation. Any kind of vegetation will hold the soil and help resist the desertification. This looks so tempting theoretically, but can this feat be achieved actually? With advancements in technology, the efficiency of solar panels is increasing, but political instability and infighting in countries like Chad and Sudan may result in disaster for projects of this magnitude. Further, distribution of generated electricity to other parts of the world possesses another challenge. What do you think? Can this be achieved? This is all for today's episode. Thanks for watching. Please subscribe for more of such videos. See you in the next episode. Till then, take care.